Section 8. Robot Construction Rules. The rules listed below explicitly address legal parts and materials and how those parts and materials may be used on a rebuilt robot. A robot is an electromechanical assembly built by the FRC robotics competition team to play the current season's game and includes all the basic systems required to be an active participant in the game: power, communications, control, bumpers, and movement about the field. A bumper is a protective assembly designed to attach to the exterior of the robot and constructed as specified in Section 8.4 Bumper Rules. There are many reasons for the structure of the rules, including safety, reliability, parity, creation of a reasonable design challenge, adherence to professional standards, impact on the competition, and compatibility with the kit of parts. The KOP, kit of parts, is the collection of items listed on the current season's kickoff kit checklist, distributed to teams via first choice in the current season, or paid for completely, except shipping, with the product donation voucher, PDV, from the current season. Another intent of these rules is to have all energy sources and active actuation systems on the robot, e.g. batteries, compressors, motors, servos, cylinders, and their controllers, drawn from a well-defined set of options. This is to ensure that all teams have access to the same actuation resources and that the inspectors are able to accurately and efficiently assess the legality of a given part. Robots are made up of components and mechanisms. A component is any part in its most basic configuration which cannot be disassembled without damaging or destroying the part or altering its fundamental function. A mechanism is an assembly of components that provide specific functionality on the robot. A mechanism can be disassembled and then reassembled into individual components without damage to the parts. Many rules in this section reference commercial off-the-shelf COTS items. A COTS item must be a standard, i.e. not custom order part commonly available from a vendor for all teams for purchase. To be a COTS item, the component or mechanism must be in an unaltered, unmodified state, with the exception of installation or modification of any software. Items that are no longer commercially available but are functionally equivalent to the original condition as delivered from the vendor are considered COTS and may be used. Blue box. Example 1. A team orders 2 robot grippers from RoboHand Corp. and receives both items. They put one in their storeroom and plan to use it later. Into the other, they drill lightning holes to reduce weight. The first gripper is still classified as a COTS item, but the second gripper is now a fabricated item and it has been modified. Example 2. A team obtains openly available blueprints of a drive module commonly available from Wheels R Us Inc. and has local machine shop We Make It Inc. manufacture a copy of the parts for them. The produced part is not a COTS item because it is not commonly carried as a part of the standard stock of We Make It Inc. Example 3. A team obtains openly available design drawings from a professional publication during the preseason and uses them to fabricate a gearbox for the robot during the build period following kickoff. The design drawings are considered a COTS item and may be used as raw material to fabricate the gearbox. The finished gearbox itself would be a fabricated item and not a COTS item. Example 4. A COTS part that has non-functional label markings added would still be considered a COTS part, but a COTS part that has device-specific mounting holes added is a fabricated item. Example 5. A team has a COTS single board processor version 1.0, which can no longer be purchased. Only the COTS single board processor version 2.0 may be purchased. If the COTS single board processor version 1.0 is functionally equivalent to its original condition, it may be used. Example 6. A team has a COTS gearbox which has been discontinued. If the COTS gearbox is functionally equivalent to its original condition, it may be used. A vendor is a legitimate business source for COTS items that satisfies all the following criteria. A. Has a federal tax identification number. In cases where the vendor is outside of the United States, they must possess an equivalent form of registration or license with the government of their home nation that establishes and validates their status as a legitimate business licensed to operate within that country. B. Is not a wholly owned subsidiary of a FRC robotics competition team or collection of teams. While there may be some individuals affiliated with both a team and the vendor, the business and activities of the team and vendor must be completely separable. C. Should maintain sufficient stock or production capability so they are able to ship any general, i.e. non-first unique product within 5 business days of receiving a valid purchase request. It is recommended that certain unusual circumstances, such as a global supply chain disruption and or 1,000 first teams all ordering the same part at once from the same vendor, may cause atypical delays in shipping due to back orders for even the largest vendors. Such delays due to higher than normal order rates are excused. This criterion may not apply to custom-built items from a source that is both a vendor and a fabricator. Blue box. For example, a vendor may sell flexible belting that the team wishes to procure to use as treads on their drive system. The vendor cuts the belting to a custom length from standard shelf stock that is typically available, welds it into a loop to make a tread, and ships it to a team. The fabrication of the tread takes the vendor 2 weeks. This would be considered a fabricated item, and the 2-week ship time is acceptable. Alternatively, the team may decide to fabricate the treads themselves. To satisfy this criterion, the vendor would just have to ship a length of belting from shelf stock, i.e. a COTS item, to the team within 5 business days and leave the welding of the cuts to the team. D. Makes their products available to all FRC robotics competition teams. A vendor must not limit supply or make a product available to just a limited number of FRC robotics competition teams. Blue box. The intent of this definition is to be as inclusive as possible to permit access to all legitimate sources while preventing ad hoc organizations from providing special purpose products to a limiting subset of teams in an attempt to circumvent the cost accounting rules. FRC desires to permit teams to have the broadest choice of legitimate sources possible and to obtain COTS items for the sources that provide them with the best prices and level of service available. Teams also need to protect against long delays in availability of parts that will impact their ability to complete their robot. The build season is brief, so the vendor must be able to get their product, particularly first unique items, to a team in a timely manner. Ideally, chosen vendors should have national distributors, e.g. Home Depot, Lowe's, MSC, McMaster-Carr, etc. Remember, FRC robotics competition events are not always near home. When parts fail, local access to replacement materials is often critical. A fabricated item is any component or mechanism that has been altered, built, cast, constructed, concocted, created, cut, heat-treated, manufactured, machined, modified, painted, produced, surface-coated, or conjured partially or completely into the final form in which it will be used on the robot. Blue box. Note that it is possible for an item, typically raw materials, to be neither COTS nor a fabricated item. For example, a 120-inch length of aluminum which has been cut into 60-inch pieces by the team for storage or transport is neither COTS, it's not in the state received from the vendor, nor a fabricated item. The cuts were not made to advance the part towards its final form on the robot. Teams may be asked to provide documentation proving the legality of non-rebuilt kit of parts items during inspection, where a rule specifies limits for a legal part, e.g. pneumatic items, current limits, COTS, electronics, etc. Some of these rules make use of English unit requirements for parts. If your team has a question about a metric equivalent parts legality, please email your question to the FRC Robotics Competition Kit of Parts team at frcparts@firstinspires.org for an official ruling. To seek approval from alternate devices for inclusion in future FRC Robotics competition seasons, please contact the Kit of Parts team at frcparts@firstinspires.org with item specifications. Teams should acknowledge that support provided by the corporate sponsors and mentors with an appropriate display of their school and sponsors' names and or logos, or the name of the supporting youth organization if appropriate. FRC Robotics competition can be a full contact competition and may include rigorous gameplay. While the rules aim to limit severe damage to robots, teams should design the robots to be robust. 8.1 General Robot Design. R101. Robot perimeter must be fixed. The robot, excluding bumpers, must have a robot perimeter contained within the bumper zone and established while in the robot's starting configuration that is comprised of fixed, non-articulated structural elements of the robot. Minor protrusions no greater than a quarter inch, such as bolt heads, fastener ends, weld beads, and rivets, are not considered part of the robot perimeter. Blue box. To determine the robot perimeter, wrap a piece of string around the outermost parts of the robot, excluding bumpers, at the bumper zone described in R405 and pull it taut. The string outlines the robot perimeter. Example: a robot's chassis is shaped like the letter U, with a large gap between chassis elements on the front of the robot. When wrapping a taut string around this chassis, the string extends across the gap and resulting field robot perimeter is a rectangle with 4 sides. Figure 8-1, robot perimeter example. R102. Starting configuration, no overhang. In the starting configuration, the physical configuration in which a robot starts a match, no part of the robot shall extend outside the vertical projection of the robot perimeter, with the exception of its bumpers and minor protrusions such as bolt heads, fastener ends, rivets, cable ties, etc. Blue box. If a robot is designed as intended and each side is pushed up against a vertical wall in starting configuration and with bumpers removed, only the robot perimeter or minor protrusions will be in contact with the wall. The allowance for minor protrusions in this rule is intended to allow protrusions that are both minor in extension from the robot perimeter and cross-sectional area. If a robot uses interchangeable mechanisms per I-103, teams should be prepared to show compliance with this rule and R-105 in all configurations. R-103, robot weight limit. The robot weight must not exceed 115 pounds. When determining weight, the basic robot structure and all elements of all additional mechanisms that might be used in a single configuration of the robot shall be weighed together, see I-103. For the purposes of determining compliance with the weight limitations, the following items are excluded. A. Robot bumpers. B. Robot battery and its associated half of the Anderson cable quick connect/disconnect pair, including wire, the associated cable lugs, connecting bolts and insulation, and C. Tags used for location detection systems if provided by the event. R104. Starting configuration max size. A robot starting configuration may not have a robot perimeter greater than 110 inches and may not be more than 30 inches tall. Blue box. Be sure to consider the size of the robot on its cart to make sure it will fit through doors. Also consider the size of the robot to ensure that it will fit into a shipping crate, vehicle, etc. Note that rules contained in Section 8.4 bumper rules may impose additional restrictions on robot design. R105. Robot horizontal extension limit. Robots may not extend more than 12 inches beyond the vertical projection of their robot perimeter. Blue box. Teams should expect to have to demonstrate a robot's ability to constrain itself per above during inspection. Constraints may be implemented with either hardware or software. R106. Horizontal extension, one direction at a time. Robots may not extend beyond their robot perimeter in more than one direction, i.e., over more than one side of the robot at a time. The extension may not reach outside the projection of that side of the robot perimeter. For the purposes of this rule, a round or circular section of frame perimeter is considered to have an infinite number of sides. Momentary and inconsequential extensions in multiple directions are an exception to this rule. Blue box. Examples of momentary and inconsequential actions include a wire or cable tie swinging out of the robot perimeter, including while an extension is deployed out a different side. Examples of compliance and non-compliance of this rule are shown in Figure 8-3. Yellow bars represent the limits of the robot perimeter and are drawn in the same orientation of the robot's perimeter. Green bars represent a measured extension from the robot perimeter that does not exceed the limits defined in R105. Robot A violates this rule for extending in more than one direction. Robot B violates this rule for extending in more than one direction. Robot C does not violate this rule. Robot D does not violate this rule as the additional extension is momentary and inconsequential. Robot E does not violate this rule. Robot F violates this rule for extending in more than one direction by extending over a round segment of robot perimeter. R107. Robot vertical extension limit. Robots may not extend such that their total height exceeds 30 inches. Blue box. This measurement is intended to be made as if the robot is resting on a flat floor without changing the robot configuration, not relative to the current height of the robot from the field carpet at any given time, i.e., the measurement is made perpendicular to the robot perimeter polygon. R108. Robot extension floor interaction. Robot extensions may not interact with the carpet, bumps, or tower base such that the bumpers are lifted out of the bumper zone. See R405. 8.2. Robot safety and damage prevention. R201. No digging into carpet. Traction devices must not have surface features that could damage the arena, e.g. metal, sandpaper, inflexible studs, cleats, hook loop fasteners, or similar attachments. Traction devices include all parts of the robot that are designed to transmit any propulsive and or braking forces between the robot and field carpet. R202. No exposed sharp edges. Protrusions from the robot and exposed surfaces on the robot shall not pose hazard to the arena elements, including scoring elements or people. Blue box. Note that the use of acrylic or other materials which may break into jagged pieces is not explicitly prohibited, but any such breakage must be corrected immediately to comply with this rule. R203. General safety. Robot parts shall not be made from hazardous materials, be unsafe, cause an unsafe condition, or interfere with the operations of other robots. Blue box. Examples of items that will violate this rule include, but are not limited to: A. Shields, curtains, or any other device or materials designed or used to obstruct or limit the vision of any drive team members and or interfere with their ability to safely control their robot. B. Speakers, sirens, air horns, or other audio devices that generate sound at a level sufficient to be a distraction. C. Any devices or decorations specifically intended to jam or interfere with the remote sensing capabilities of another robot, including vision systems, acoustic rangefinders, sonar, infrared proximity detectors, etc., e.g. including imagery on your robot that utilizes or closely mimics 36H11 April tags. D. Lasers other than those listed as IEC/EN 60825-1 Class 1 or IEC-EN 62471 exempt. E. Flammable gases. F. Any device intended to produce flames or pyrotechnics. G. Hydraulic fluids or hydraulic items. H. Switches or contacts containing liquid mercury. I. Circuitry used to create voltages in excess of 24 volts. J. Any ballast not secured sufficiently, including loose ballast, e.g. sand, ball bearings, etc., such that it may become loose during a match. K. Hazardous materials, e.g. lead, whether encapsulated or not, used on the robot. L. High-intensity light sources such as the robot, e.g. super bright LED sources marketed as military-grade or self-defense, may only be illuminated for a brief time while targeting and may need to be shrouded to prevent any exposure to participants. Complaints about the use of such light sources will be followed by reinspection and possible disablement of the device. And M. Bright lights which flash more than approximately 5 times per second, per E108. R204. Leave scoring elements at the field. Robots must allow removal of scoring elements from the robot and the robot from field elements while disabled and powered off. Blue box. Robots will not be re-enabled after the match, so teams must be sure that scoring elements and robots can be quickly, simply, and safely removed. Teams are encouraged to consider G501 when developing their robots. R205. Don't contaminate the field. Liquids, gels, greases, and fine particles must not contaminate the field or other robots. R206. Don't damage scoring elements. Robots' elements likely to come in contact with a scoring element shall not pose a significant hazard to the scoring element. Blue box. Scoring elements are expected to undergo a reasonable amount of wear and tear as they are handled by robots, such as scratching or marking. Gouging, tearing off pieces, or routinely marking scoring elements are violations of this rule. 8.3. Budget constraints and fabrication schedule. R301. Individual item cost limit. No individual, non-KOP item or software shall have a fair market value FMV that exceeds $600 US. The total cost of components purchased in bulk may exceed $600 US as long as the cost of an individual component does not exceed $600 USD. Blue box. Teams should be ready to show inspectors documentation of fair market value for any components that appear to be in the range of the $600 USD limit. The Analog Devices IMU MXP Breakout Board, part number ADIS 16448, does not have a published fair market value. This device is considered to comply with this rule regardless of its true fair market value. The FMV, or fair market value, of a COTS item is its price defined by a vendor for the part or an identical functional replacement. This price must be generally available to all FIRST Robotics competition teams throughout the build and competition season, i.e., short-term sale prices or coupons do not reflect FMV. However, Teams are only expected to make a good faith effort at determining the item price and are not expected to monitor prices of robot items throughout the season. The FMV is the cost of the item itself and does not include any duties, tariffs, taxes, shipping, or other costs that may vary by locality. The FMV of COTS software is the price set by the vendor to license the software or piece of the software that runs on the robot for the period from kickoff to the end of the first championship. The fair market value of software license free of cost, including through the virtual kit of parts for use on the robot, is 0. The FMV of fabricated parts is the value of the material and or labor except for labor provided by team members, including sponsor employees who are members of the team, members of other teams, and or event-provided machine shops. Material costs are accounted for as the cost of any purchasable quantity that can be used to make the individual part, i.e., the purchasable raw stock is larger than the fabricated item. Example 1. A team orders a custom bracket made by a company to the team specification. The company's material cost and normally charged labor rate apply. Example 2. A team receives a donated sensor. The company would normally sell the item for $450 USD, which is therefore its fair market value. Example 3. A team purchases titanium tube stock for $400 USD and has it machined by a local machine shop. The machine shop is not considered a team sponsor but donates 2 hours of expended labor anyway. The team must include the estimated normal cost of the labor as if it were paid to the machine shop and add it to the $400 USD. Example 4. A team purchases titanium tube stock for $400 USD and has it machined by a local machine shop that is recognized sponsor of the team. If the machinists are considered members of the team, their labor costs do not apply. The total applicable cost for the part would be $400 USD. It is in the best interest of the teams and FRC to form relationships with as many organizations as possible. Recognizing and supporting companies as sponsors of and members in the team is encouraged, even if the involvement of the sponsor is solely through the donation of fabrication labor. Example 5. A team purchases titanium tube stock for $400 USD and has it machined by another team. The total applicable cost for the part would be $400 USD. Example 6. A team purchases a widget at a garage sale or online auction for $300, but it's available for sale from a vendor for $700. The fair market value is $700. If a COTS item is part of a modular system that can be assembled in several possible configurations, then each individual module must fit within the price constraints defined in this rule. If the modules are designed to assemble into a single configuration, and the assembly is functional in only that configuration, then the total cost of the complete assembly, including all modules, must fit within the price constraint defined in this rule. In summary, if a vendor sells a system or a kit, a team must use the entire system/kit fair market value and not the value of its component pieces. Example 7. Vendor A sells a gearbox that can be used with a number of different gear sets and can mate with 2 different motors they sell. A team purchases the gearbox, a gear set, and a motor, then assembles them together. Each part is treated separately for the purposes of determining fair market value since the purchase price can each be used in various configurations. Example 8. Vendor B sells a robotic arm assembly that a team wants to use. However, it costs $630 USD, so they cannot use it. The vendor sells the hand, wrist, and arm as separate assemblies for $210 each. A team wishes to purchase the 3 items separately, then reassemble them. This would not be legal as they are really buying and using the entire assembly, which has a fair market value of $630 USD. Example 9. Vendor C sells a set of wheels or wheel modules that are often used in groups of 4. The wheels or modules can be used in other quantities or configurations. A team purchases 4 and uses them in the most common configuration. Each part is treated separately for the purposes of determining FMV since the purchased pieces can be used in various configurations. R302, Major Mechanism from this year only. Major mechanisms as defined in I-101 created before kickoff are not permitted. Blue box. Neither this rule nor the language in this blue box defines specific thresholds for how much of a major mechanism must be constructed after kickoff. This rule expects and requires that teams' honest assessment of whether they built the major mechanism of their robot after kickoff. Attempts to exploit loopholes in the definition of major mechanism in order to bypass this requirement are in the spirit of neither this rule nor FRC Robotics competition. Examples of exploitation include: A. Pre-assembling significant portions of a major mechanism prior to kickoff and attaching those assemblies together post-kickoff. B. Removing a small component of a major mechanism prior to kickoff such that it is no longer a major mechanism and replacing it after kickoff. R303. Create new designs and software unless they're public. Robot software and designs created before kickoff are only permitted if the source files, complete information sufficient to produce the design, are available publicly prior to kickoff. Blue box. Example 1. A team realizes that the transmission designed and built in the fall perfectly fits their need for a transmission to drive the robot arm. They'll build an exact copy of the transmission from the original design plans and bolt it to the robot. This would be prohibited as the transmission, although made during the competition season, was built from detailed designs developed prior to kickoff. Example 2. A team developed an omnidirectional drive system for the 2019 competition. In July 2019, they refined and improved the control software written in C++ to add more precision and capabilities. They decided to use a similar system for the rebuilt competition. They copied large sections of unmodified code over into the control software of the new robot, also written in C++. This would be a violation of the schedule constraint and is not allowed. Example 3. The same team decides to use LabVIEW as their software environment for rebuild. Following kickoff, they use the previously developed C++ code as a reference for the algorithms and calculations required to implement their omnidirectional control solution. Because they developed new LabVIEW code as they ported over their algorithms, this is permitted. Example 4. A different team develops a similar solution during the fall and plans to use the developed software on their competition robot. After completing the software, they post it in a generally accessible public forum and make the code available to all teams. Because they have made their software publicly available before kickoff, they can use it on their robot. Example 5. A team develops a transmission prior to kickoff. After completing the project, they publish the CAD files on a generally accessible public forum and make them available to all teams. Because they have made the design publicly available before kickoff, they can use the design to create an identical transmission fabricated after kickoff for use on their rebuilt robot. 8.4. Bumper rules. A bumper is a required assembly which attaches to the robot frame. Bumpers protect robots from being damaged by other robots and field elements. A bumper guide providing additional information on materials and design based on historical best practices may be found under the Mechanical Resources section of the Technical Resources page. Teams may also reference the kitbot instructions for a detailed step-by-step on how to build bumpers for the kitbot. All dimensions specified in this section are nominal and will be measured during inspection with a tolerance of a 1/4 inch unless otherwise specified. This means that maximums specified have a tolerance of plus 1/4 inch and minimums specified have a tolerance of minus 1/4 inch. Teams are encouraged to design to the nominal dimension and reserve the tolerance for unexpected deviations such as manufacturing error or tolerance stack-up. R401. Bumpers almost all around. Robots are required to use bumpers to protect the entire robot perimeter. Gaps of less than 1.25 inches between adjacent segments are permitted as long as all corners are filled per R406. A single gap larger than 1.25 inches is permitted as long as at least 5 inches of robot perimeter on each side of each corner is protected by bumper. Blue box. An arc is considered to have infinite corners and therefore it may not have a gap larger than 1.25 inches. R402. Bumper construction. Bumpers must consist of the following. A. Padding. A minimum of 2.25 inches depth of foam padding, at least 4.5 inches tall, consisting of solid blocks, sheets, or stacked rods of one or more of the following materials. Solid pool noodles or backer rod. Solid polyethylene closed-cell foam, including cross-linked, with density between 1.5 and 3 pounds per cubic foot. Solid EVA closed foam with density between 2 and 6 pounds per square foot for cubic foot. And 4. Foam floor tiles. Multiple types, shapes, and/or layers of foam may be used within a single bumper. Blue box. Teams should be prepared to provide information about the padding material used in their bumpers. Teams do not need to have a separate material sample for exposed padding for direct inspection to show compliance with this rule. B. Backing. A backer at least 4.5 inches tall, which supports the padding, i.e. padding is not cantilevered other than in corners, and facilitates installation and removal of the bumper from the robot, as noted in R410. Additional elements may be added to strengthen the backing, fill space between the bumper and robot frame, serve as part of the attachment system, or for any other purpose. C. Cover. Cloth, as noted in R411, which covers all outward, upward, and downward facing surfaces of padding such that no padding is exposed to interaction with the field or other robots. D. Fastening system. Bumpers must attach to the robot perimeter with a rigid fastening system to form a tight, robust connection to the main structure/frame, e.g. not attached with hook and loop tape, or cable ties. The fastening system must be designed to withstand vigorous gameplay. All removable fasteners, e.g. bolts, locking pins, quick-release pins, etc., may be considered part of either the bumpers or robot for determination of weight per R103 and R408. Blue box. The bumper rules provide teams significant freedom in choosing designs and materials. For information on reference designs, see the bumper guide under the Mechanical Resources section of the Technical Resources page. R403, Bumper Extension Limit. Bumpers must not extend more than 4 inches from the robot perimeter. R404, bumpers must be soft. Hard parts of bumpers must not extend more than 1 1/4 inches out from the robot perimeter. Only padding per R402A, cover per R402C, including any coatings or markings, and soft fasteners used to secure padding or cover are permitted beyond this limit. Padding must extend at least 2 inches beyond any hard parts of the bumper. There is no limit on how far bumper hard parts may extend inside the robot frame perimeter. Blue box. Hard parts include any items which are likely to cause damage to the cloth or padding of other bumpers, such as nuts and bolts, cable ties, hard plastic, etc. R405. Bumpers interact with bumpers. While navigating the field normally, all bumpers must have padding per R402A, supported by backing per R402B, entirely filling the bumper zone, a space between 2.5 inches and 5.75 inches from the floor. Blue box. This measurement is intended to be made in a robot's expected configuration or configurations while navigating the field and is relative to whatever surface the robot is currently driving on. Bumpers leaving the bumper zone due to robots inadvertently tipping is not a violation of this rule. R406. Fill bumper corners. Corner joints between bumpers must be filled with uncompressed padding material extending at least 2.25 inches from the corner with no gaps or voids. Example of implementation are shown in Figure 8-10. Figure 8.10, uncompressed corner padding wrapped around corner OK. Blue box. Separate bumper segments meeting at a miter in the corner are not considered to fill the corner due to the cloth covering and do not meet the requirements of this rule. R407. Bumpers shouldn't be wedges. Bumpers must not act as wedges when interacting with other bumpers. Blue box. Examples of bumpers which might act as a wedge and may invite additional scrutiny include A. Bumpers utilizing softer foam towards the top of a bumper profile. B. Bumpers utilizing excessively rounded profiles such as a single semicircle, and C. Bumpers with tapered or stepped padding such that the padding is thinner or thicker towards the top or bottom. R408. Weight limit with bumpers. The total weight of the robot as described in R103 with bumpers must not exceed 135 pounds. R409. Bumpers should be passive. Bumpers must be fixed relative to the robot perimeter. Bumpers may not contain any moving elements beyond compression and flex of bumper materials or electrical elements. R410. Bumpers must come off. Bumpers must be designed for installation and removal to facilitate inspection and weighing. Blue box. As a guideline, bumpers should be able to be installed or removed by 2 people in fewer than 5 minutes. R411. Bumpers indicate your alliance. Each robot must be able to display red or blue bumper covers to reflect their alliance color as assigned in the match schedule distributed at the event, as described in Section 10.1, Match Schedules. Contrasting markings on outward, upward, or downward facing surfaces of the bumper cover other than the following are prohibited. A. Those required per R412. B. Hook and loop tape, snap fasteners, or functional equivalents backed by the hard parts of the bumper. C. Solid white first logos between 4.75 inches and 5.25 inches wide, comparable to those available in the rebuilt virtual kit. And D. Narrow areas of underlying cloth exposed at seams, corners, or folds. R412. Team numbers on bumpers. Team numbers must be displayed and positioned on the bumper cover in at least 3 locations approximately 90 degrees apart, such that an observer walking around the perimeter of the robot can unambiguously tell the team's number from most points of view, from as far as approximately 720 inches. Team numbers must meet the following additional criteria. A. Consists of only white Arabic numerals at least 3.75 inches high, at least a half inch in stroke width. Blue box. The half-inch stroke width requirement applies to the majority of the stroke. Font elements less than a half-inch, such as serifs, rounded edges, small hairlines, or gaps, etc., are permitted as long as the majority of the stroke meets the sizing requirements and the numbers are unambiguous. B. Must not wrap around sharp corners less than 135 degrees of the robot perimeter. C. Must not split individual digits such that the team number is ambiguous. And blue box. As a guideline, spacing between digits or groups of digits which exceed 4 inches may be ambiguous. D. May not substitute logos or icons for numerals. Blue box. There is no prohibition against splitting team numbers onto different sections of bumper. The intent is that the team's number is clearly visible and unambiguous so that judges, referees, announcers, and other teams can easily identify competing robots. This marking is intended to display the team number only, not to intentionally change the surface characteristics of the bumper. Excessive material usage as part of any team number marking will invite close scrutiny. 8.5. Motors and actuators. R501. Allowable motors. The only motors and actuators permitted include the following in any quantity. Indy Mark 9015, Neverest, PG, Redline motor, and Snowblower motor. Bainbots 775, RS 550, etc. Sim, a number of variants. CTR Electronics Minion, CTR Electronics / Vex Robotics Falcon 500, current / former kit of parts automotive motors, Playing with Fusion Venom, Rev Robotics HD Hex, Rev Robotics Neo Brushless, Rev Neo 450, Neo Vortex, Thrifty Bot Pulsar 775, Vex Bag, Vex Minisim, WCP Kraken X44, Kraken X60, RS775 Pro, fans no greater than 120 millimeters nominal size, rated electrical input power no greater than 10 watts, continuous duty at 12 volts. Hard drive motors, part of a legal COTS computing device, factory installed vibration, and autofocus motors resident in COTS computing devices, e.g. rumble motor in a smartphone. PWM COTS rotational servos with stall current less than or equal to 4 amps and mechanical output power of less than or equal to 8 watts at 6 volts. PWM COTS linear servos with max stall current less than 1 amp or equal to 1 amp at 6 volts. Motor integral to a COTS sensor, e.g. LiDAR, scanning, sonar, etc., provided the device is not modified except to facilitate mounting. 1. Compressor compliant with R806 and used to compress air for the robot's pneumatic system. COTS brushed motors, linear actuators, electrical solenoid actuators, or electromagnets rated for 12 volts and wired to an approved power regulating device downstream of a breaker, 20 amps or less. Electrical solenoid actuators or electromagnets used at 24 volts must be rated to 24 volts. Blue box. For servos, note that the RoboRio is limited to a max current output of 2.2 amps on the 6-volt rail, 12.4 watts of electrical input power. Teams should make sure that their total servo power usage remains below this limit at all times. Servo mechanical output power is approximated by the following formula using 6-volt data reported by manufacturer. Mechanical output power in watts is equal to 0.25 times stall current in newton meters times no load speed in radians per second. This calculator from the first Tech Challenge documentation can be used to help calculate output power from inputs of various units. Given the extensive amount of motors allowed on the robot, teams are encouraged to consider the total power available from the robot battery during the design and build of the robot. Drawing large amounts of current from many motors at the same time could lead to drops in robot voltage that may result in tripping the main breaker or triggering the brownout protection of the RoboRio. For more information about the RoboRio brownout protection and measuring current draw using the PDP/PDH, see RoboRio brownout and understanding current draw. Any marked PG globe gear motors are sold with labeling based on the entire assembly. Assemblies labeled AM3651 through AM3656 contain legal motors specified in Table 8-1. These motors may be used with or without the provided gearbox. R502, only 4 propulsion motors. A robot may not have more than 4 propulsion motors. A propulsion motor is a motor that enables the robot to move around the field surface. Motors that generate small amounts of thrust as a secondary or incidental feature are not considered propulsion motors. Blue box. Examples that are not considered propulsion motors include A. Motors that primarily alter the alignment of a wheel in contact with the field surface, such as a swerve steering motor. B. Motors that run mechanism wheels, e.g., for scoring element manipulation that occasionally happen to contact the carpet but without enough force to generate significant thrust. And C. Motors that change the speed of the drive wheels using a shifting mechanism without significantly contributing to propulsion. R503. Don't modify motors mostly. The integral mechanical and electrical system of any motor must not be modified. Motors, servos, and electrical solenoids used on the robot shall not be modified in any way except as follows. A. The mounting brackets and or output shaft/interface may be modified to facilitate the physical connection of the motor to the robot and actuated part. B. The electrical leads may be trimmed to length as necessary and connectors or splices to additional wiring may be added. C. The locking pins on the window motor, part number 262-100-3030 and 262-100-3040, may be removed. D. The connector housings on kit of parts automotive motors listed in Table 8-1 may be modified to facilitate lead connections. E. Servos may be modified as specified by the manufacturer, e.g. reprogramming or modification for continuous rotation. F. Minimal labeling may be applied to indicate device purpose, connectivity, functional performance, etc. G. Any number of 1032 plug screws may be removed from the Falcon 500 and the Kraken X60. H. Insulation may be applied to electrical terminals. I. Repairs provided the original performance and specifications are unchanged. J. Maintenance recommended by the manufacturer. Blue box. The intent of this rule is to allow teams to modify mounting tabs and the like, not to gain a weight reduction by potentially compromising the structural integrity of any motor. R504. Power most actuators off of approved devices. With the exception of servos, fans, or motors integral to sensors of COTS computing devices permitted in R501, each actuator must be controlled by a power regulating device. The only power regulating devices for actuators permitted on the robot include A. Motor controllers, A. Course 40 motor controller, B. Spark Flex motor controller, C. Spark motor controller, D. Spark Max motor controller, E. Talon FX motor controller, F. Talon FXS motor controller, G. Talon motor controller, H. Talon SRX motor controller, I. Thrifty Nova, J. Venom motor with controller, K. Victor SP motor controller, and L. Victor SPX motor controller. B. Relay modules. A. Spike 8 bridge relay. B. Automation direct relay. C. Power distribution hub, PDH, switch channel for controlling non-actuator custom circuits only. C. Pneumatics controller. A. Pneumatics control module, and B. Pneumatics hub. D. Servo controllers. A. Servo hub, part number Rev 11-1855. Blue box. Note, the automation direct relays are single directional. Per R504, they may not be wired together in an attempt to provide bidirectional control. R505. Don't overload controllers. Each power regulating device may control electrical loads per Table 8-2 unless otherwise noted. Each power regulating device shall control one and only one electrical load. And there is a table of values of R506. Control servos safely. Servos must be connected to and only to one of the following. A. PWM ports on the RoboRio. B. PWM ports on a WCP Spartan sensor board. C. Rev Robotics Servo Power Module. Or D. Rev Robotics Servo Hub. 8.6. Power distribution. In order to maintain safety, the rules in this section apply at all times while at the event, not just while the robot is on the field for matches. R601. Battery limit. Everyone has the same power. The only legal source of electrical energy for the robot during competition, the robot battery, must be one and only one non-spillable sealed lead acid SLA battery with the following specifications. A. Nominal voltage 12 volts. B. Nominal capacity at 20-hour discharge rate, minimum 17 amp hours, maximum 18.2 amp hours. C. Shape rectangular. D. Nominal dimensions 7.1 inches by 3 inches by 6.6 inches plus or minus 0.1 inch for each dimension. E. Nominal weight 11 to 14.5 pounds. F. Terminals nut and bolt style. G. Battery vents must not be obstructed. Blue box. Nut and bolt style refers to any style battery terminal where the connector is secured to the battery using a threaded fastener. Examples of batteries which meet these criteria include Enersys, MK Battery, Battery Mart, Sigma, Universal Power, Power Patrol, Worker Battery, Powersonic, USA, Panasonic, Interstate Batteries, Duracell Ultra Battery. Teams should be aware that they may be asked to provide documentation of the specifications of any battery not listed above. Batteries should be charged in accordance with manufacturer specifications. Please see the first safety manual for additional information. R602. Other batteries for cameras or computers only. COTS USB battery packs with a capacity of 100 watt-hours or less, with 5 volt/5 amp max output or 12 volt 5 amp max output using USB PD per port. Batteries integral to and part of COTS computing devices, or self-contained cameras, e.g. laptop batteries, GoPro-style cameras, etc., or batteries used to power CMOS/RTC features may be used to power COTS computing devices and any peripheral COTS input or output device connected to the COTS computing device provided they are A. Securely fastened to the robot, B. Connected only using unmodified COTS cables, and C. Charged according to manufacturer recommendations. Blue box. A COTS computing device is a non-RoboRio device used to process or collect sensor information. E.g., a smart flashlight is not a COTS computing device. R603. Charge batteries with safe connectors. Any battery charge used to charge a robot battery. Any battery charger used to charge a robot battery must have the corresponding Anderson SP connector installed. R604. Charge batteries at a safe rate. Any battery charger used to charge a robot battery may not be used such that it exceeds 6 amps average charge current. R605. Batteries are not ballast. No batteries other than those allowed per R601 and R602 are allowed on the robot, whether or not they are being used to supply power. Blue box. For example, teams may not use additional batteries as extra weight on their robots. R606. Secure the battery. The robot battery must be secured such that it will not dislodge during vigorous robot interactions, including if the robot is turned over or placed in an arbitrary orientation. R607. Insulate battery connections. Each electrical terminal on the robot battery, main breaker, and their connections, lugs, stripped wire ends, etc., to the wire must be fully insulated at all times. R608. Limit non-battery energy. Non-electrical sources of energy used by the robot, i.e. stored at the start of the match, shall come only from the following sources. A. Compressed air stored in the pneumatic system that has been charged in compliance with R806 and R807. B. A change in the altitude of the robot center of gravity. C. Storage achieved by deformation of robot parts. D. Closed-loop COTS pneumatic gas shocks. Or E. Air-filled pneumatic wheels. R609. Connect main power safely. The following devices shall be connected with 6 AWG copper wire or larger as shown in Figure 8-11. A. One robot battery. B. A single pair of Anderson Power Products or APP 2-pole SB connectors. C. A single main 120 amp surface mount circuit breaker. And D. A single main power distribution device, PD. A. CTR Electronics Power Distribution Panel, PDP. B. CTR Electronics Power Distribution Panel 2.0. C. Rev Robotics Power Distribution Hub. Or D. Amped Power Distribution, AMPD. Amped. No additional devices or modifications shall be permitted with the following exceptions. E. Monitoring circuitry permitted by R625. F. SB50 to SB120 adapters, provided they have been presented for inspection. G. Termination of wires with appropriate cable lugs and or blue box. SB type refers to SB type only, e.g. SB50, SB120, etc., not SBS or any other part type beginning with SB. All batteries supplied by FRC, such as spare parts and international batteries, will have a red or pink SB50 connector installed, which may not be removed. The pink connector included in the kit of parts mate with the red SB50 connector. While pure copper wire is recommended, copper-clad aluminum wire is considered copper wire. R610. One breaker/fuse per circuit. All circuits, with the exception of those listed in R615 and R617, must connect to and have power sourced solely by a single protected connector pair of the PD. Circuits must not connect to the main power input of the PD. R611. The robot frame is not a wire. All wiring and electrical devices shall be electrically isolated from the robot frame. The robot frame must not be used to carry electrical current. Blue box. Compliance with this rule is checked by observing a greater than 120 ohm resistance between either the positive or negative post within the APP connector that is attached to the power PD and any point on the robot. All legal motor controllers with metal cases are electrically isolated. They may be mounted directly to robot frame components. Note that some cameras, decorative lights, and sensors, e.g. some encoders, some IR sensors, etc., have grounded enclosures or are manufactured with conductive plastics. These devices must be electrically isolated from the robot frame to ensure compliance with this rule. R612 must be able to turn robot on and off safely. The 120 amp circuit breaker must be quickly and safely accessible from the exterior of the robot. This is the only 120 amp circuit breaker allowed on the robot. Blue box. Examples considered not quickly and safely accessible include breakers covered by an access panel or door, or mounted on, underneath, or immediately adjacent to moving components. It is strongly recommended that the 120 amp circuit breaker location be clearly and obviously labeled so it can be easily found by field staff if needed. While the main breaker must be accessible, consider positioning or shielding it such that it is protected from accidental actuation, e.g. it's unlikely to be hit by a scoring element during gameplay. R613. Electrical system must be inspectable. The PD, associated wiring, and all circuit breakers must be visible for inspection. Blue box. Visible for inspection does not require that the item be visible when the robot is in starting configuration, provided the team can make the item viewable during the inspection process. R614. No high voltage allowed. Any active electrical item that is not an actuator specified in R501 or core control system item specified in R710 is considered a custom circuit. Custom circuits shall not produce measurable voltages exceeding 24 volts with the exception of COTS Power over Ethernet PoE injector devices used with COTS Ethernet cables and COTS receiving devices, i.e. not a breakout or adapter. R615. Power Robo-Rio as specified. The Robo-Rio power input must be connected directly to a non-switched pair of protected output terminals of a PD with a 10 amp fuse or circuit breaker installed. R616. Power radio as specified, Part 1. The wireless bridge radio power must be connected based on the radio type. A. For VH109 radios, radio power must be sourced from one or both of A. injected into the Rio port of the radio using a passive injector or modified Ethernet cable connected directly to a PD or B, wired directly to the 12-volt power input of the radio from a PD. B, for OM5P radios, China events only, you can read it, and then B, this is for the, yes, okay, blue box. Note that this prohibits using any other active PoE injector device to power the radio, but does not prohibit using any passive connectors to inject the VRM power into an Ethernet cable plugged into the OM5P radio port labeled 18 to 24 volt PoE. Please reference How to Wire an FRC Robot for wireless bridge wiring information. R617, Power Radio as specified, Part 2. The device supplying power to the wireless bridge per R616 must be connected directly to a non-switched pair of protected output terminals of a PD with a 10 amp fuse or circuit breaker installed, with the exception of the PDP 1.0 shared VRM/PCM pairs, which may be protected with a 20 amp fuse or circuit breaker. R618. Use PD terminals as designed. Only one wire shall be connected to each terminal on the PD. Blue box. If multi-point distribution of circuit power is needed, e.g. to provide power to multiple PCMs and or VRMs from a single 20 amp circuit, then all incoming wires may be appropriately spliced into the main lead, e.g. using an insulated terminal, block crimped splice or soldered wire splice, and the single main lead inserted into the terminal to power the circuit. R619. Only use specified circuit breakers in a PD. The only circuit breakers permitted for use in the PD are A. Snap Action VB3-A series or AT2-A terminal style F57 40 amp rating or lower. B. Snap Action MX5-A or MX5-L series 40 amp rating or lower. C. Rev Robotics ATO auto resetting breakers 40 amp rating or lower. D. CTR Electronics ATO auto resetting breakers 40 amp rating or lower. And E. Any ATM circuit breaker with value less than or equal to the fuses permitted per R620. R620. Only use specified fuses in PD. The only fuses permitted for use in the PD are automotive blade fuses with the following values. A. For the PDP, ATM-style fuses with values matching the values printed on the device's corresponding fuse holder. B. For all PDs, ATC/ATO-style fuses with values 10 amps or lower. And C. For the PDH, ATM-style fuses with values 15 amps or lower, with the exception of a single 20 amp fuse for powering a PCM or PH. Blue box. Note that these fuses must be pressed very firmly to seat properly. Improper seating can cause a device to reboot upon impact. R621. Protect circuits with appropriate circuit breakers. Each branch circuit must be protected by one and only one circuit breaker or fuse on the PD per table 8-3. No other electrical load can be connected to the breaker or fuse supplying this circuit, with the exception of devices downstream of a permitted motor power adapter board placed between the PD and a motor controller. WCP 1380, RF 4003, RF 4004, RF 4005. Table 8-3. Branch circuit protection requirements. Motor controller, breaker or fuse up to 40 amps, only one allowed per breaker. Custom circuit up to 40 amp breaker, no limit on the number allowed per breaker. Automotive direct relay 40 amp, up to 40 amp, only one allowed per breaker. FAMs permitted up to 20 amp and no limit per breaker. Spike relay module up to 20 amp and only one allowed per breaker. Automation direct relay 25 amps, up to 20 amp breaker, only one allowed per breaker. PCM/PH with compressor up to 20 amps, one allowed per breaker. Servo power module/servo hub up to 20 amps, only one allowed per breaker. Additional VRM, non-radio/additional PCM/PH non-compressor up to 20 amp breaker, 3 allowed per breaker. Automation direct relay 12 amp, up to 10 amp breaker, only one allowed per breaker. Blue box. This rule does not prohibit the use of smaller value breakers in the PD or any fuses or breakers within custom circuits for additional protection. Fans permitted per R501 may also be included with custom circuits. R622. Use appropriately sized wire. All circuits shall be wired with appropriately sized insulated copper wire. Signal level cables don't have to be copper. For a 31 to 40 amp breaker, requires 12 AWG minimum, 20 minimum sized. 21 to 30 amp breaker protection circuit require 14 AWG wire or larger. 6 to 20 amp breaker protected circuit requires, 11 to 20 amp fuse protected circuit, and between the PDH dedicated terminals and the VRM/RPM or PCM/PH and compressor outputs from the PCM/PH require 18 AWG or larger. Motor power adapter board protected circuit and less than or equal to 5 amp breaker protected circuits or less than or equal to 10 amp fuse protected circuits require 22 AWG or larger. VRM 2 amp circuits less than or equal to 2 amp fuse protected circuits and VH 109 pass through per R626 require 24 AWG wire or larger. Robo Rio PWM port outputs or less than or equal to 1 amp fuse protected circuits require 26 AWG or larger. Signal level circuits, i.e. circuits which draw less than or equal to 1 amp continuous and have a source incapable of delivering greater than 1 amp, including but not limited to Robo Rio non-PWM outputs, CAN signals, PCM/PH solenoid outputs, VRM 500 milliamp outputs, RPM outputs, and Arduino outputs require 28 AWG or larger. Wires that are recommended by the device manufacturer or originally attached to legal devices are considered part of the device and by default legal. Such wires are exempt from this rule, provided they are powered by the smallest value fuse or breaker, which permits proper device operation. Blue box. In order to show compliance with these rules, teams should use wire with clearly labeled sizes if possible. If unlabeled wiring is used, teams should be prepared to demonstrate that the wire used meets the requirements of this rule, e.g., wire samples and evidence that they are the required size. While pure copper wire is recommended, copper-clad aluminum wire is considered copper wire. R623. Use only appropriate connectors. Branch circuits may include intermediate elements such as COTS connectors, splices, COTS flexible/rolling/sliding contacts, and COTS slip rings, as long as the entire electrical pathway is via appropriately gauged/rated elements. Blue box. Slip rings containing mercury are prohibited per R203. R624. Use specified wire colors mostly. All non-signal level wiring with a constant polarity, i.e. except for outputs of relay modules, motor controllers, or sensors, shall be color-coded along their entire length from the manufacturer as follows. A. Red, yellow, white, brown, or black with stripe on the positive, e.g. plus 24 volt DC, plus 12 volt DC, plus 5 volt DC, etc. connections. B. Black or blue for the common or negative side of the connections. Exceptions to this rule include C. Wires that are originally attached to legal devices and any extension to these wires using the same color as the manufacturer, or D. Ethernet cables used in PoE cables. R625. Don't modify critical power paths. Custom circuits shall not directly alter the power pathways between the robot battery, PD, motor controllers, relays per R504-B, motors and actuators per R501, pneumatic solenoid valves, or other elements of the robot control system, items explicitly mentioned in R710, custom high-impedance voltage monitoring or low-impedance current monitoring circuitry connected to the robot's electrical system is acceptable if the effect on the robot outputs is inconsequential. Blue box. A noise filter may be wired across motor leads or PWM leads. Such filters will not be considered custom circuits and violate neither this rule nor R712. Acceptable signal filters must be fully insulated and must be one of the following. 1 microfarad or less non-polarized capacitor may be applied across the power leads of any motor on your robot as close to the actual motor lead as reasonably possible, or A resistor may be used as a shunt load for the PWM control signal feeding a servo. R626. VH109 PoE pass-through. The VH-109 PoE output may be used only under the following conditions. A. The device being powered is a COTS device or COTS adapter connected to a single COTS device with current draw less than or equal to 2 amps at 12 volts. B. The connection is made using standard Cat5e678 cable. And C. The VH109 is powered using the 12-volt input terminal with 18 AWG wire or larger. It may additionally be powered using the PoE input if desired. 8.7. Control command and signal systems. R701. Control the robot with a RoboRio. Robots must be controlled via one programmable NI RoboRio or RoboRio 2.0, both versions referred to throughout this manual as RoboRio, with image version 2026 v1.2 or later. Blue box. There are no rules that prohibit coprocessors provided commands originate from the RoboRio to enable and disable all power regulating devices. This includes motor controllers legally wired to the CAN bus. R702. Communicate with the robot with the specified radio. One Vivid Hosting wireless bridge, part number VH109, West Coast Products-1538, that has been configured with appropriate encryption key for your team member at each event, is the only permitted device for communicating to and from the robot during the match. Events held in China are the exception to this rule and must use open mesh radio. R703. Use specific Ethernet port for RoboRio. The RoboRio Ethernet port must be connected as specified. A. For VH109 v1.5 radios, to the port labeled Rio either directly via a Cat5 Ethernet pigtail or via a passive PoE injector cable or adapter. B. For VH109 v1.0 radio, either directly or via Cat5 Ethernet pigtail. A. To the radio port labeled Rio via a passive PoE injector cable or adapter, whether or not it is used to power the radio, or an Ethernet cable with the appropriate wires removed on the RoboRio end. All wires or adapters used must be fully insulated. Or B. To the radio port labeled AUX1 or AUX2 with the corresponding dip switches in the off position, default position. C. For OM5P radios, China only, etc., etc. Blue box. Note. Placing a switch between the RoboRio and radio may impede the ability for field staff to troubleshoot RoboRio connection issues on the field. Teams may be asked to connect directly between the radio and the RoboRio as part of troubleshooting efforts. If not using the Rio port of the VH109 1.0, it is strongly recommended to cover the port to prevent accidental damage to devices such as laptops, which may occur if attached to this port. R704. Only use allowed ports and bandwidth to communicate with the robot. Communication between the robot and the operator console may not exceed the following and is restricted to network ports listed in Table 8-5. A. 7 megabits per second for Vivid Hosting wireless bridge radios, and 4 megabits per second for open mesh radios. And they list all the bidirectional ports, UDP, TCP 1180 through 1190, etc., and suggested usage. Teams may use these ports as they wish. If they do not employ them as outlined above, i.e. TCP 1180 can be used to pass data back and forth between the robot and the driver station software if the team chooses not to use the camera on USB. Blue box. Note that the 4 megabit limit will be strictly enforced by the wireless bridge. The FMS white paper has more details on how to check and optimize bandwidth usage, while FIRST makes every effort to provide a wireless environment that allows teams access to a full 4 megabits per second data rate, with about 100 kilobit used for robot control and status. At some events, wireless conditions may not accommodate this. R705. Configure devices for your team member. The RoboRio, driver station software, and wireless bridge must be configured to correspond to the correct team number per the procedure defined in the FIRST Robotics Competition Control System documentation. R706. Don't bypass the arena network. All signals must originate from the operator console and be transmitted to the robot via the Arena Ethernet network. R707. Limited wireless allowed. The only forms of wireless communication that may be used to communicate to, from, or within the robot include A. Those required per R702 and 706. B. Tags used for location detection systems if provided by the event. And C. RFID or NFC systems used exclusively within the robot. Blue box. Devices that employ signals in the visual spectrum, e.g. cameras and non-RF sensors that don't receive human-originated commands, e.g. beam brake sensors or IR sensors on the robot, used to detect field elements are not wireless communication devices, and thus this rule doesn't apply. R708. Wireless bridge must be visible. The wireless bridge must be mounted on the robot such that the diagnostic lights are visible to field staff. Blue box. Teams are encouraged to mount the wireless bridge away from noise-generating devices such as motors, PCMs, PHs, and VRMs/RPMs. R709. Robots must have a signal light. Robots must use at least one, but no more than two, diagnostic robot signal lights, RSL. Any RSL must be A. Mounted on the robot such that it is easily visible while standing 36 inches away from at least one side of the robot. B. Connected to the RSL supply terminals on the RoboRio, and C. If using the 855PB-PB12ME522, wired for solid light operation by placing a jumper between the LA and LB terminals on the light, per figure 8-13. Blue box. Please see how to wire an FRC robot for connection details. R710. Only specified modifications to control system devices permitted. The driver station software, RoboRio, PD, PCMs, PHs, VRMs, RPMs, RSL, 120 amp breaker, motor controllers, MXP devices used to control actuators per R713-C, relay modules per R504-B, wireless bridge, PD breakers and fuses, servo power modules, servo hub, power motor adapter boards, and batteries shall not be tampered with, modified, or adjusted in any way. Tampering includes drilling, cutting, machining, rewiring, disassembling, painting, etc., with the following exceptions. Blue box. Please note that the driver station software is a separate application from the dashboard. The driver station software may not be modified, while teams are expected to customize their dashboard code. A. User programmable code in the RoboRio may be customized. B. Motor controllers may be calibrated as described in owner's manuals. C. Fans may be attached to motor controllers and may be powered from the power input terminals. D. If powering the compressor, the fuse on a spike H-bridge relay may be replaced with a VB3A-20 amp snap action circuit breaker. E. Wires, cables, and signal light lines may be connected via the standard connection points provided on the devices. F. Fasteners, including adhesives, may be attach the device to the operator console or robot, or to secure cables to the device. G. Thermal interface material may be used to provide heat conduction. H. Labeling may be applied to indicate device purpose, connectivity, functional performance, etc. I. Jumpers may be changed from their default location. J. Limit switch jumpers may be removed from a Jaguar microcontroller, and a custom limit switch circuit may be substituted. Okay. K. Device firmware may be updated with manufacturer-supplied firmware. L. Integral wires on motor controllers may be cut, stripped, and/or connectorized. M. Devices may be repaired, provided the performance and specifications of the device after the repair are identical to those before the repair. N. The cover may be removed from the Talon SRX or Talon FX data port. O. Electrical tape may be applied to the aluminum plate inside the wireless bridge. P. The input terminal cover from the PDP may be omitted. No other element may be installed using the threaded holes to install something in place of the PDP terminal cover. Q. RoboRio 2.0 SD card may be replaced with an SD card of any capacity. R. Adding insulating materials to exposed conductors. S. Replacing control system power terminal blocks, e.g. RSL power connectors with functional equivalents. T. Tape may be applied for debris protection. U. VH-109V1.0 may be upgraded to VH-109V1.5 using manufacturer materials and instructions. Blue box. Please note that while repairs are permitted, the allowance is independent of any manufacturer's warranty. Teams make repairs at their own risk and should assume that any warranty or return options are forfeited. Be aware that diagnosing and repairing components such as these can be difficult. For more information about modifications, please see this OM5P-AC radio modification article. R711. Don't connect motor outputs to RoboRio. Neither 12-volt DC power nor relay module or motor controller output shall be connected directly to the RoboRio, with the exception of designated 12-volt DC input. R712. Control PWM controllers from the RoboRio. Every relay module per R504-B, servo power module, and PWM power controller shall be connected to a corresponding port, relays to relay ports, servos and PWM controllers to PWM ports on the RoboRio, either directly or through a WCP Spartan sensor board, or via a legal MXP connection per R713. They shall not be controlled by signals from any other source. R713. Only approved MXP devices can control actuators. If a motor is controlled via the MXP, its power regulating device must be connected by one of the following methods. A. Directly to any PWM pins. B. Via a network of passive conductors used to extend the PWM pins. Or C. Via one approved active device. A. Kawaii Labs NavX MXP, Kawaii Labs NavX 2 MXP, C. RCal MXP daughter board, Rev Robotics Rio Duino, Rev Robotics Digit board, West Coast Products Spartan sensor board, Husky Robotics Husky 2.0 board. Blue box. A passive conductor is any device or circuit whose capability is limited to the conduction and or static regulation of the electrical energy applied to it, e.g. wire, splices, conductors, printed wiring board, etc. An active device is any device capable of dynamically controlling and or converting a source of electrical energy by the application of external electrical stimulus. The network of passive conductors only applies to the pins being used for PWM output to motors or servos. This means that connecting an active device, such as a sensor, to one MXP pin does not prevent other MXP pins from being used in accordance with B. R714. Control CAN motor controllers from the RoboRio. Each CAN motor controller must be controlled with enable/disable input source from the RoboRio and passed via either a PWM wired per R713 or CAN bus, either directly or daisy-chained via another CAN bus device signal, but both shall not be wired simultaneously on the same device. Blue box. As long as the CAN bus is wired legally so that the heartbeat from the RoboRio is maintained, all closed-loop control features of the CAN motor controller may be used. That is, commands originating from the RoboRio to configure, enable, and specify an operating point for all CAN motor controller closed-loop modes fit the intent of R701. Wired directly includes via any series of passive conductors, i.e. star or hub configurations using only passive conductors are permitted. R715. Control PCM, PH, and servo hub from RoboRio. Each pneumatic control module, PCM, pneumatic hub, PH, and servo hub must be controlled with signal inputs sourced from the RoboRio and passed via a CAN bus connection from the built-in CAN on the RoboRio, either directly or daisy-chained via another CAN bus device. R716. Don't alter the CAN bus. No device that interferes with, alters, or blocks communication among the RoboRio and the PCMs/PHs and or CAN motor controllers on the bus will be permitted. Blue box. Only one wire should be inserted in each Voigtmuller CAN connector terminal. For documentation on how to wire the CAN bus connections, see how to wire an FRC robot. R717. USB to CAN adapter permitted. Additional CAN bus connections may be added to the RoboRio using the CTRE Electronics Canivore USB to CAN adapter. Blue box. Any additional CAN bus added in this manner satisfies the requirements of R714, i.e. you may connect motor controllers to this additional bus. 8.8. Pneumatic system. In order to maintain safety, the rules in this section apply at all times while at an event, not just while the robot is on the field for matches. R801. Only use explicitly permitted pneumatic parts. To satisfy multiple constraints associated with safety, consistency, inspection, and constructive innovation, no pneumatic parts other than those explicitly permitted in this section shall be used on the robot. R802. No custom pneumatics and meet minimum pressure ratings. All pneumatic items must be COTS pneumatic devices and either A. rated by their manufacturer for pressures of at least 125 psi, or B. installed downstream of the primary relieving regulator, C R809, and rated for pressures of at least 70 psi. Blue box. Any pressure specification, such as working, operating, maximum, etc., may be used to satisfy the requirements of this rule. It is recommended that all pneumatic items be rated by their manufacturers for a working pressure of at least 60 psi. R803, don't modify pneumatics. All pneumatic components must be used in their original unaltered condition. Exceptions are as follows. A. Tubing may be cut. B. Wiring for pneumatic devices may be modified to interface with the control system. C. Assembling and connecting pneumatic components using the pre-existing threads, mounting brackets, quick connect fittings, etc. D. Removing the mounting pin from a pneumatic cylinder, provided the cylinder itself is not modified. And E. Labeling applied to indicate device purpose, connectivity, functional performance, etc. Blue box. Do not, for example, paint, file, machine, or abrasively remove any part of a pneumatic component. This would cause the part to become a prohibited item. R804. Only use specified pneumatic devices. The only pneumatic system items permitted on robots include the following items. A. Pneumatic pressure vent plug valves, functionally equivalent to those provided in the kit of parts. Blue box. Examples of accessible valves include Parker PV609-2 or MV709-2. B. Pressure relief valves, functionally equivalent to those provided in the kit of parts. Blue box. Examples of acceptable valves include Norgren 16-004-011, 16-004-003, or McMaster-Carr 48435K714. To be considered functionally equivalent, the valve must be preset or adjustable to the 125 psi and capable of relieving at least one SCFM. C. Solenoid valves with a maximum 1/8-inch nominal NPT, BSPP, or BSPT port diameter or integrated quick connect 1/4-inch outside diameter tubing connection. D. Additional pneumatic tubing with a maximum 1/4-inch outside diameter. E. Pressure transducers, pressure gauges, passive flow control valves, specifically needle valves, manifolds, and connecting fittings, including COTS pneumatic U-tubes. F. Check and quick exhaust valves, provided that the requirements of R813 are still met. G. Shutoff valves, which relieve downstream pressure to atmosphere when closed, may also be known as three-way or three-way exhausting valves. H. Pressure regulators with the maximum outlet pressure adjusted to no more than 60 psi. I. Pneumatic cylinders, pneumatic linear actuators, and rotary actuators. J. Pneumatic storage tanks, with the exception of white clippered tanks, part number AVT-PP-41. K. One compressor that is compliant with R806. L. Debris or coalescing water filters, and M. Venturi valves. Note, the high-pressure side of a Venturi valve is considered a pneumatic device and must follow all pneumatic rules. The vacuum side of a Venturi valve is exempt from the pneumatic rules per A in the blue box below. Blue box. The following devices are not considered pneumatic devices and are not subjected to pneumatic rules, though they must satisfy all other rules. A. A device that creates a vacuum. B. Closed-loop COTS pneumatic gas shocks. C. Air-filled pneumatic wheels. And D. Pneumatic devices not used as part of a pneumatic system, i.e., used in a way that does not allow them to contain pressurized air. R805. If using pneumatics, these parts are required. If pneumatic components are used, the following items are required as part of the pneumatic circuit and must be used in accordance with this section, as illustrated in Figure 8-14. A. One first robotics competition legal compressor per R806. B. A pressure relief valve per R804-B, connected and calibrated per R811. C. A Nason pressure switch, part number given, and or Rev Robotics analog pressure switch, part number given, connected and wired per R812. D. At least one pressure vent plug plumb per R813. E. Stored pressure gauge and working pressure gauge per R810. And F. One primary working pressure regulator per R808. Figure 8-14, pneumatic circuitry. Shows relief valve, compressor, storage tanks, etc. R806, compressed air from robot compressor only. Throughout an event, compressed air on the robot must be provided by its one onboard compressor only. Compressor specifications must not exceed nominal 1.1 cubic feet per minute. flow rate at 12 volt DC at any pressure. Blue box. A robot's compressor may be substituted by another compressor, but a robot may only have one designated compressor at a time, and all compressed air on the robot must be sourced from a single compressor. Note: Viair C-Series compressors, which have a maximum working pressure of 120 psi, are rated for intermittent pressures greater than 125 psi and are therefore meet the requirements of this rule. R807, Air Storage Pressure Limit. Stored air pressure on the robot must be no greater than 120 psi. No stored air pressure intended for the robot may be located off-board the robot. R808, Working Air Pressure Limit. Working air pressure used to actuate devices on the robot must be no greater than 60 psi and must be provided through a single primary adjustable relieving pressure regulator. Additional regulators may be located downstream of the single primary regulator. Blue box. Examples of acceptable valves include Norgren regulator part number R07-100-RNEA and Monnier part number 101-3002-1. R809, Limited devices at high pressure. Only the compressor, relief valve, pressure switch, pressure vent plug, pressure gauge, storage tanks, tubing, pressure transducers, filters, and connecting fittings may be in the high-pressure pneumatic circuit upstream from the regulator. Blue box. It is recommended that all components in the high-pressure pneumatic circuit upstream from the regulator be rated for at least 115 psi. R810. Pressure gauges must be visible. Pressure gauges must be placed in an easily visible locations upstream and downstream of the regulator to display the stored and working pressures, respectively. Pressure gauges must show pressure in psi, kPa, or bar. R811. Relief valve requirements. The relief valve must be attached directly to the compressor or attached by legal hard fittings, e.g. brass, nylon, etc., connected to the compressor output port. Teams are required to check and or adjust the relief valve to release air at 125 psi. The valve may or may not have been calibrated prior to being supplied to teams. Blue box. Instructions for adjusting the pressure relief valve can be found in the pneumatics manual. R812. Pressure switch requirements. The pressure switch must be connected to the high pressure side of the pneumatic circuit, i.e. prior to the pressure regulator. To sense the stored pressure of the circuit, it must be either A. Nason part number SM-2B-115R/443 wired as described, and or the two wires from the pressure switch must be connected directly to the pressure switch input of the PCM/PH controlling the compressor, or, if controlled using the Robo-Rio and a relay, to the Robo-Rio. If connected to the Robo-Rio must be programmed to sense the state of the switch and operate the relay module that powers the compressor to prevent overpressuring the system. B. Rev Robotics part number Rev-11-1107 wired as described. The analog output of the sensor must be connected directly to analog input 0 of the pH with firmware version 22.0.2 or newer, controlling the compressor. Blue box. The Rev Robotic analog pressure sensor may only be used with pH compressor control and may not be used with PCM compressor control. R813. Vent plug requirements. Any pressure vent plug must be A. Connected to the pneumatic circuit such that, when manually operated, it will vent to the atmosphere to relieve all stored pressure in a reasonable amount of time, and B. Placed on the robot so that it is visible and easily accessible. R814. Don't connect solenoid outputs together. The output air from multiple solenoid valves must not be combined. Blue box. Manifolds, shuttle valves, and other devices which do not combine output airflow, even though it may be plumbed into the same device, are not violations of this rule. 8.9. Operator console. R901. Use the specified driver station software. The driver station software provided by National Instruments, install instructions found here, is the only application permitted to specify and communicate with the operating mode, i.e. auto/teleop, and operating state, enabled, disabled, to the robot. The driver station software must be version 26.0 or newer. Blue box. Teams are permitted to use a portable computing device of their choice, laptop, computer, tablet, etc., to host the driver station software while participating in matches. R902. The operator console must have a visible display. The operator console, the set of components and mechanisms used by the drivers and/or human players to relay commands to the robot, must include a graphical display to present the driver station software diagnostic information. It must be positioned within the operator console so that the screen display can be clearly seen during inspection and in a match. R903. Connect FMS Ethernet directly to the operator console. Devices hosting the driver station software must only interface with the FMS via the Ethernet cable provided at the driver station, e.g. not through a switch. Teams may connect the FMS Ethernet cable to the device running the driver station software directly via an Ethernet pigtail, or with a single port Ethernet converter, e.g. docking station, USB Ethernet converter, Thunderbolt Ethernet converter, etc. The Ethernet port on the operator console must be easily and quickly accessible. Blue box. Teams are strongly encouraged to use pigtails on the Ethernet port used to connect to the FMS. Such pigtails will reduce wear and tear on the device's port and will, with proper strain relief employed, will protect the port from accidental damage. R904. Operator console physical requirements. The operator console must not A. Be longer than 60 inches, B. Be deeper than 16 inches, excluding any items that are held or worn by the drivers during the match, C. Extend more than 78 inches above the floor, or D. Attached to the field except via the loop tape as described in section 5.9.1 driver stations, or clamping to the driver station support shelf as long as the shelf is not damaged. Glue box. There is a 54-inch long by 2-inch wide strip of hook and loop tape along the center of the driver station support shelf that should be used to secure the operator console to the shelf. See section 5.9.1 driver stations for details. Please note that while there is no hard weight limit, operator consoles that weigh more than 30 pounds will invite extra scrutiny as they are likely to present unsafe circumstances. R905. Field wireless only. Other than the system provided by the field, no other form of wireless communication shall be used to communicate to, from, or within the operator console. Blue box. Examples of prohibited wireless systems include, but are not limited to, active wireless network cards and Bluetooth devices. For the case of the first robotics competition, a motion sensing input device, e.g. Microsoft Kinect, is not considered wireless communication and is allowed. R906. No unsafe operator consoles. Operator consoles shall not be made using hazardous materials, be unsafe, cause an unsafe condition, or interfere with other drive teams or the operation of other robots. R907. No AC inverters. Operator consoles must not contain AC inverters.